To the live session. Today we are going to discuss coordination compounds. Come to the live session, my dear students. That is just yes, come to the my dear students. Today we are going to discuss coordination compounds. Coordination compounds. Come to the live session, all of you. Coordination compounds. Coordination compounds. Please subscribe my channel and share. Subscribe and share. Comment. So these are useful for those are preparing for EAPCET examination in Andhra and Telangana. So today in Andhra, intermediate examination results are came. Then before yesterday in Telangana, intermediate exam results are there. Then you people must be prepared for the JEE mains and you people must be prepared for EAPCET examination, right? So that's what I told. So better to prepare. Then if you prepare 1 month exactly, so not even 1 month, actually May 7th EAPCET examination will be there. The 7th, 8th, 9th, 10th. 8th, 9th, 10th in Telangana. Please share, come to the live session. Come to the live session, all of you. Today we are going to discuss about the coordination compounds. Yes, my name is Lakshmanana. This is Ellen Brand of Chemistry. Today we are going to discuss coordination compounds. So before going to coordination compounds, one of the good news for you people I have to share to you. That is yesterday I achieved 1,000 subscribers. Yes, clear? Thank you for your support. Thank you for your love and support to me. Then those are truly preparing for the EAPCET examination. Please support me and share my channel to others. Okay, come to the point. So what are the coordination compounds first? Sir, weight ni manam coordination compounds antam. Sir, ikkada ఏవైనా 2 compounds ని యాడ్ చేయడం ద్వారా అడిషన్ కాంపౌండ్స్ అనేటివి ఫామ్ అవుతాయి. ఈ అడిషన్ కాంపౌండ్స్ అనేటివి 2 types గా ఉంటాయి. What are those? Any compounds, the combination of any 2 stable compounds, we can get 2 types of compounds. Sir, what are those? Double salts and coordination compounds. So first of all, addition compounds అంటే ఏంటి? అడిషన్ కాంపౌండ్స్ అంటే by addition of 2 stable compounds are called addition compounds. So these addition compounds are 2 types. What are those? Double salt, then coordination compounds. Double salts, coordination compounds. Sir, what are the double salts? Double salts ante enti? కోఆర్డినేషన్ కాంపౌండ్స్ అంటే ఏంటి? ఫస్ట్ వీ హ్యావ్ టు డిస్కస్ అబౌట్ ద డబుల్ సాల్ట్. Sir, after the addition of two salts, one of the compound is formed, addition compound is formed, that is we are calling it as a double salt. Even by the formation of double salt form అయిన తర్వాత కూడా, so before forming, after forming, sir, whatever the ions are present in the particular compounds that are not lost their identity. Sir, ఏ కాంపౌండ్స్ అయితే దాని ఐడెంటిటీని లాస్ అవ్వవో, సో అలాంటి కాంపౌండ్స్ని మనం డబుల్ సాల్ట్స్ అంటున్నాం. ఫర్ ఎగ్జాంపుల్ ఇఫ్ ఐ టేక్ KCl, actually by the dissolution of KCl it can get K plus Cl minus, then MgCl2 if you take, then Mg plus 2 plus 2Cl minus you can get. So by the addition of both salts, the KCl plus MgCl2, by the addition of both, we can get KCl MgCl2, then hydrated salt, that is 6H2O. Look at, sir, ఇది డబుల్ సాల్ట్ అంటున్నాం. డబుల్ సాల్ట్, ఈ డబుల్ సాల్ట్ ఆఫ్టర్ యాడింగ్ వాటర్ని మళ్ళీ యాడ్ చేస్తే, అంటే డిజాల్వ్ చేస్తే, so again it can get K plus ions, then Cl minus ions, then Mg plus 2 ions you can get. The same ions K plus, then Cl minus, then Mg plus 2 ions వస్తాయి. So after formation of double salt, the before formation of double salt, whatever the ions identity will be there. So before and after, that identity never lost. So such type of compounds we are calling double salts. వాటిని మనం ఏమంటున్నాం? డబుల్ సాల్ట్స్. Sir, what are the coordination compounds? Coordination compounds అంటే, sir, by the addition of two salts, two compounds, stable compounds, then that can lose their identity of ions. How it is? Look at once. Then FeCN taken twice, one of the salt, by the addition of potassium cyanide, the 4 moles of potassium cyanide. Once both we are added, then you can get it is K4 FeCN taken 6, like this will be formed. So this is we are calling coordination compound. దీన్నే మనం కోఆర్డినేషన్ కాంపౌండ్ అంటున్నాం. ఈ కోఆర్డినేషన్ కాంపౌండ్ ఆఫ్టర్ ద అడిషన్ ఆఫ్ వాటర్ యాడ్ చేసినప్పుడు, then it can gives K plus plus, then FeCN taken 6 minus 4. సో ఇలా డిఫరెంట్ అయాన్స్ ఇస్తుంది. అదే KCN వాటర్లో యాడ్ చేస్తే K ప్లస్ CN మైనస్ వస్తుంది. ఐరన్ని యాడ్ చేస్తే Fe plus 2 CN minus 2 వస్తుంది, CN minus వస్తుంది. బట్ after the formation of coordination compounds, it won't give Fe plus 2 ions or CN minus ions. It won't form. It can form K plus and FeCN taken 6 minus 4. ఇలాంటి సాల్ట్స్ ఫామ్ అవుతాయి. So look at these salts we are calling coordination compounds. సో ఏవైతే దాని ఐడెంటిటీ, దాని ఆయాన్స్ యొక్క ఐడెంటిటీని లాస్ అవుతుందో అలాంటి కాంపౌండ్స్ని మనం కోఆర్డినేషన్ కాంపౌండ్స్ అంటాం. సో దే విల్ ఆస్క్ ఎ క్వశ్చన్, విచ్ ఆఫ్ ద ఫాలోయింగ్ ఆర్ కోఆర్డినేషన్ కాంపౌండ్స్, విచ్ ఆఫ్ ద ఫాలోయింగ్ ఆర్ డబుల్ సాల్ట్స్. సో we have to identify that which is double salt, which is coordination compound. Clear, my dear students? Yes. So now I will give one of the question to you, which is coordination compound, which is double salt. It is one of the previous year question. It is one of the previous year question. So look at, so which of the following is coordination compound? Coordination compound. They are given like this. The question is there like this. Then option A they are mentioned, that is KCl MgCl2, 6H2O. Then one more, B is given, K2SO4, NH4 taken twice SO4, then 24H2O. Then option C they are mentioned, 2, sorry, FeCN taken twice, 4KCN. Then option D, none of the above, like this is given. So observe the question carefully. Sir, which are the double salts and which are the double salts and which are coordination compounds? So these two are double salts. Then this is coordination compound. So how can you say it is a coordination compound? By the addition of both, what will be formed? I told Fe, so K4, it is a counter ion, FeCN taken 6, like this will be formed. Observe it carefully. Yes, look, my dear students. So this is one of the question. Based on which is coordination compound, which is double salt. Edi double salt to edi coordination compound ani explain chese question adi. Okay. Yes, come to the point. First, if you come to the coordination compounds, sir, first some of the terms you have to understand what are the important to discuss the coordination compounds. Coordination compounds ni discuss cheyalante konni terms neeku telisi undali. So what are those that we have to discuss? For example, nenu oka compound తీసుకున్నా CO NH3 taken 6, then close the bracket like this, then next Cl3, like this will be there. Yes, my dear students. So look at all of you. Sir, here CO is there, right? So this is actually central metal atom. So whatever the metal will be there inside the coordination entity. Sir, which is coordination entity? Sir, ఈ స్క్వేర్ బ్రాకెట్ ఏదైతే మెన్షన్ చేశామో, ఈ స్క్వేర్ బ్రాకెట్ ఏదైతే మెన్షన్ చేశామో దాన్నే మనం కోఆర్డినేషన్ ఎంటిటీ ఆర్ స్పియర్, coordination sphere we call. Okay, then these are ammonia, these are we call ligands. Sir, what are the ligands, sir? Sir, which can donate lone pair of electrons to central metal atom. So ligands it may be ions ga undochu, or it may be neutral molecules kuda undochu. Then so some of the cations also present, cations kuda undochu. So anions, then neutral molecules, and cations also present, that are ligands. So ligands in this, the molecule or ion or neutral, negative ion or positive ion, which can donate lone pair of electrons to the central metal atom. ఏదైతే లోన్ పేర్ ఆఫ్ ఎలక్ట్రాన్స్ ని సెంట్రల్ మెటల్ ఆటమ్ కి డొనేట్ చేయగలదు దాన్ని మనం లిగాండ్ అన్నాం. The number here, the number is there 6, taken 6. This is we call coordination number. దీన్ని మనం coordination number అంటాం. Coordination number. So what is the coordination number, sir? So number of ligands or the number of coordinate covalent bonds which are directly attached to the metal atom ki direct ga attach cheyina coordinate covalent bonds. దీన్ని ఎలా ఫైండ్ అవుట్ చేస్తాం? కోఆర్డినేషన్ నంబర్, ఇట్ ఈస్ ఈక్వల్స్ టు డెన్సిటీ ఇంటూ నంబర్ ఆఫ్ లిగాండ్స్. Denticity into number of ligands. Just to remember the formula, we'll discuss later what is the coordination number, how to calculate it. Then coordination entity ki outside unna ion edaina, so danni manam counter ion antam. Counter ion. So this we call counter ion. This we call coordination number. These are ligands. This is central metal atom. Clear, my dear students? Understand, all of you? Yes. Then now, so ligands, what are the ligands will be there that we have to discuss this. సరే ఏవైతే లిగాండ్స్ అని మనం డిస్కస్ చేశామో ఈ లిగాండ్స్ అనేవి మోనోడెంటేట్ లిగాండ్స్, ambidentate ligands, bidentate ligands, hexadentate ligands, tridentate ligands, tetradentate ligands, like this will be present. So ligand nothing but a molecule or ion which can donate lone pair of electrons to the central metal atom are called ligands. So ligand nothing but a molecule or ion which can donate lone pair of electrons to the central metal atom are called ligands. So ligands actually, so many types such as monodentate ligand, monodentate ligands. Sir, what are the monodentate ligands? So they are ligand which contain only one donor atom, only one coordinate covalent bond. It can form only one coordinate covalent bond. It can form only one coordinate covalent bond. It can form only one coordinate covalent bond. It contains only one donor atom. From the donor atom we can get lone pair of electrons. For example, my dear students, for the monodentate ligands are NH3. Here lone pair of electrons are there, it can donate to the central metal atom. Then H2O, then lone pair of electrons are there, it can donate. Then in case OH minus, lone pair of electrons are there, Cl minus, Br minus, I minus, etc. So whatever the molecules are there, these all are monodentate ligands. So monodentate ligands nothing but which can donate only one lone pair of electrons to the central metal atom and form one coordinate covalent bond, that we call monodentate ligands. Understand, my dear students? Yes. Then come to the second one, that is bidentate ligand. Bidentate ligand or didentate ligand we call. Bidentate ligand or didentate ligand. So what is the bidentate ligand? So a molecule or ion which can donate two lone pair of electrons and can form two coordinate covalent bonds. A molecule which can donate two lone pair of electrons and can form two coordinate covalent bonds two coordinate covalent bonds are called bidentate ligands. Bidentate ligands. Examples are, what are the bidentate ligands? For example, in case if you take oxalate COO minus bond COO minus oxalate, then we call it as a C2O4 minus 2. Then next CO3 minus 2. Then next SO4 minus 2. Then next neutral ligands, if you take ethylene diamine, we call EN, ethylene diamine. Then all these are bidentate ligands. Then more than two donor atoms are present in case, then we call it as a polydentate ligands. So note down these 2 points, then we'll discuss one more. Yes, good evening all of you. Good evening. Good evening, my dear students. So come to the live session. Yes, what are the ligands? It is understand, right? Yes. So next we are going to discuss, that is a polydentate ligands. So polydentate ligands nothing but dentate ligands nothing but. So these can form more than two coordinate covalent bonds. More than two coordinate covalent bonds. Coordinate covalent bonds. More than two coordinate covalent bonds in kanaka form cheste, then we call it as a polydentate ligand. We call it as polydentate ligand. For example, EDTA minus 4. It is actually hexadentate ligand. Hexadentate ligand. We call it is ethylene diamine tetraacetate. Ethylene diamine tetraacetate, EDTA minus 4. So what is the original structure of ethylene? CH2 bond CH2, ethylene. Diamine, then wherever the NH2 is there, we call it as ethylene diamine, NH2, like this. Then in the place of two hydrogen atoms, look at my dear students, in the place of two hydrogen atoms, then if we add CH2, then COO minus, CH2, then COO minus. Then even in the place of two hydrogen atoms here, then CH2, COO minus. Then here CH2, then COO minus. Look at, observe it carefully. Sir, ethylene, CH2 bond CH2, ethylene, diamine. Sir, wherever the nitrogen donors are there, their lone pair of electrons are present. Then acetate, tetraacetate, I told, tetra, 4. So CH2 COO minus, CH2 COO minus, CH2 COO minus, CH2 COO minus. Totally 4 acetate ions are there, tetraacetate we call. So that is what, wherever the negative charge is there, count it, 4 are there. So that's what minus 4 were mentioned. Sir, it can form 6 coordinate covalent bonds with a metal. ఒక metal తో 6 coordinate covalent bond form చేయగలదు. How it is? Then look at two lone pair of electrons with this. Here two nitrogen atoms, two coordinate covalent bonds. Then with acetates, it can form the remaining two coordinate covalent bonds. Totally the metal surrounded by how many coordinate covalent bonds are there? Then 6 coordinate covalent bonds are there. That is what we are calling it is hexadentate ligand. What we call hexadentate ligand. So more than 2, even in case 3 donor atoms are there, if it is form 3 coordinate covalent bonds, then we call tridentate ligands. Then later that we call 4 donor atoms are there, then tetradentate ligand. So like this will be there. So now I will mention some of the monodentate ligands and negatively, positively, Then as well as neutral ligands I will mention here, even including with the names I will mention. Observe it carefully. Yes, my dear students, follow the coordination compounds, all of you. They will ask a question based on it, which is monodentate ligand, which is bidentate ligand, which is polydentate ligand, which is hexadentate ligand. Then so such type of questions they will ask. Look at some of the ligands I will mention. So such as monodentate ligands, in case if you take monodentate ligands. So observe, my dear students. So better to note all these. Then we know from the first onwards. So that is F minus fluorido. We call fluorido. Ido. It starts, it end with ido. Then Cl minus is there. Chlorido. Chlorido. Then Br minus is there. Bromido. Bromido. Then I minus is there. Iodido. 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 Then next NH2 minus, observe it carefully, my dear students. NH2 minus amido, amido. Then NH minus, yes, NH minus is there, imido, imido, amido, imido, amido, NH2 minus, imido, NH minus. Then OH minus, hydroxido, hydroxido, OH minus. Then here one more point you have to remember. Look at, observe it carefully. Sir, O2 is there, that we call oxide, oxygen. Sir, oxygen ki oka electron ni add cheste. So O2 add cheste plus 1 electron when it is add. So O2 minus you can get. So O2 minus where will be there, that we call superoxide. దీన్ని మనం సూపర్ ఆక్సైడ్ అంటాం. సో ఈ O2 మైనస్ కి మళ్ళీ ఒక ఎలక్ట్రాన్ ని యాడ్ చేస్తే ప్లస్ 1 ఎలక్ట్రాన్ ఇఫ్ యాడ్, then O2 minus 2 you can get. Then so this we call peroxide. దీన్ని peroxide అంటాం, దీన్ని సూపర్ ఆక్సైడ్ అంటాం. సో ఇలా కాకుండా జస్ట్ సింగిల్ ఆక్సిజన్ ఇస్ దేర్. ఈ సింగిల్ ఆక్సిజన్ కి 2 ఎలక్ట్రాన్స్ ని యాడ్ చేసాం. 2 ఎలక్ట్రాన్స్ ని యాడ్ చేస్తే O-2 ఫామ్ అయింది. దీన్ని ఆక్సైడ్ అంటాం. ఏమంటాం? దీన్ని ఆక్సైడ్ అంటాం. See, look at 3 different ions we can observe in the oxygen. So that is O2 minus 1, O2 minus 1. We call it as superoxide. While writing the name of ligand, superoxido or superoxo or superoxido. Then so O2 minus 2, peroxo, we call peroxo or peroxido. Then O minus 2, O2 minus 2 is peroxo. So O minus 2, oxo or oxido or oxo. We can write like this. So these all are oxygen wherever it is there. Oxygen. Then some other ligands will be there. Some other ligands as then Cn minus cyano. Then H2O. These are neutral ligands. We'll write neutral ligands later. First note it, all which are negative ligands are there. Yes, look at neutral ligands we'll discuss. Neutral ligands. Neutral ligands. The neutral ligands. Sir, in case H2O, if we take, we call aqua. Then NH3 is there, amino. Amino. NH3 is there, amino. Then CO, carbonyl. Carbonyl. Then NO, nitrosyl. Nitrosyl. Then next NH3, amino, right? Then PPH3, triphenyl. 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 So next N3 minus azido. Azido. Next N minus 3, that is nitrido. Nitrido. The next S minus 2, sulfido. The next H minus, that is hydrido. Hydrido. The next neutral ligands such as C5H5N, that is we call pyridine. Pyridine. Actually pyridine structure is, look at, it is aromatic structure. Aromatic structure. This is we call pyridine. What we call? Pyridine. So next NO plus. NO plus nitrosonium. Nitrosonium. Then next one N2H5 plus hydrogonium. Hydrogonium ion. All these are some monodentate ligands. The monodentate ligands nothing but only one coordinate covalent bond it can form. So that are neutral also is there. So some of the negative ligands also is there. Then some of the positive ligands also is there. The positive ligands are very few. So very few ligands are present. So such as NO plus, then N2H5 plus. So actually N2H5 plus it will be there like this. So this is hydrogen. Hydrogen formula NH2 bond NH2, right? Then by the addition of H plus for this H plus add cheste, then you can get it is, sir, NH2 bond, then NH3 plus. Sir, here donor atom is nitrogen. Idi metal ki donate chestum. The metal ki donate chestum. That is hydrogonium. Next NO plus lo nitrogen can donate the lone pair of electrons to that. Okay, clear? So these are the neutral ligands which we are discussing. Yes, note down all these ligands, then we'll discuss one more point here. One more point. Yes. That are bidentate ligands, my dear students. The bidentate ligands next we have to discuss. Bidentate ligands. Second one is what? Bidentate ligands. Bidentate ligands. Sir, what are those bidentate ligands? The ligands which can form two coordinate covalent bonds that we call bidentate ligands. The sulfate, carbonate, oxalate. So all these are bidentate ligands. So including with that. So first one we are writing, that is CO3 minus 2. So CO3 minus 2 original structure is C double bond O, then O minus, then O minus. These two are the coordinate covalent bonds it can form with the metal atoms. So this is we call carbonato. Carbonato. ATO. Carbonato. Then second one sulfate. that is SO4 minus 2, sulfate. Say S, then double bond O, then double bond O, then O minus, then O minus, then so like this, then sulfonato, sulfonato. Next, third one oxalato. What is oxalato? C2O4 minus 2. The original structure of C2O4 minus 2 is then C double bond O, then bond C double bond O, then O minus, then O minus. Two donor atoms with oxygen. A metal, then, so this is the metal, right? So it can form the coordinate covalent bond with this. Then this we call oxalato. Oxalato, ATO, ATO, ATO. It is end with ATO. The names of ligands are end with ATO, which are sulfate, oxalate, and then carbonate. So note down all of you. Right. So bidentate ligands. Next one. So next ligand, that is the glycinato, glycinato, glycinato. This is fourth ligand. So look at how it will be there. Glycine, we know glycine. So what is the glycine, man? Glycine, it is one of the amino acid. So what is the amino acid structure? NH2, then CH2, then COOH. Then after the removal of one hydrogen atom from here, H plus kanaka remove అయిపోయింది అనుకోండి ఇక్కడ నుంచి, then what will be formed? CH2, then COO minus, then bond NH2. Here lone pair of electrons are there, then here negative charge is there. So it can form two coordinate covalent bonds like this. So this we call, which is glycinato, which is NH2, then CH2, then COO minus, we call glycinato. It is one of the bidentate ligand. Then fifth one, my dear students, so that is we call DMG, DMG minus, that we call dimethyl glyaxymato, dimethyl glyaxymato, dimethyl glyaxymato. Yes, DMG minus, DMG minus. So how it will be present? Look at the structure. Actually, then C double bond O, bond C double bond O, bond CH3, then CH3 we call dimethyl ketone, right? So two ketones are there. In the place of ketone, in case NOH, yes, observe it is. For example, any one of the ketone will be there, or C double bond O, or like this. When it is treated with NH2OH hydroxylamine, so H2O, when it is removed from it, H2O kanaka remove cheste, so em form avutundi cheppandi? So RC or double bond NOH, clear? Understand? We call it is oxime, 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 oxime. That we call ketoxime, ketone kabatti ketoxime, aldehyde aithe aldoxime. Sir, here dimethyl glyoxime. So look at, so here in the place of O, N bond OH you can get. Yes, understand all of you? This is the original structure. Then from this, in case if you remove the hydrogen atoms from there, then negative charge of hydrogen atoms it can form, or otherwise here the lone pair of electrons are there. These lone pair of electrons it can donate lone pair of electrons to the central metal atom, that is we call DMG minus. So dimethyl glyaxymate. Okay, clear, my dear students? Understand all of you, right? Yes, next one. Next one, we'll discuss one more, that is so AC minus acetyl acetato, that is we call acetyl acetato, acetyl acetatonate, acetyl acetatonate. So how it is the original structure? Actually CH3 bond, then C double bond O bond, then CH2 bond, then C double bond O bond CH3. This is we call acetyl acetonate, acetyl acetonate. Then here one of the hydrogen, when it is removed from here, negative charge will be formed, it will be shifted to there, negative charge will be shifted to an oxygen atom, CH3 bond CO minus, then double bond CH, then bond C double bond O, CH3, like this will be formed. Yes, clear my dear students, understand all of you. So this is the original structure of acetyl acetonato. So this is also bidentate ligand. So how it is a bidentate ligand? So here the metal atom, the negative charge will be attached to there. Negative charge will be attached to there. Sir, wherever the lone pair of electrons are there, even that is also it can attach with that. Next, diurea or biurea we call. Diurea, biurea, or biurea or diurea. So, diurea or biurea we call. Urea. So, what is the diurea or biurea? So, biurea or diurea, di nothing but 2, bi also 2. The urea, what is the formula of urea? NH2 C double bond O, NH2 is there. This is we call urea. When it is combined with one more urea molecule, that is NH2, then C double bond O, NH2. Sir, here by the two molecule, by the addition of two molecule, it can loss ammonia. So indulo nunchi ammonia loss అయిపోయి, then compound how it will be formed? NH2, then C double bond O, then NH bond C double bond O, then NH2. So now here lone pair of electrons are there, here lone pair of electrons are there. So this can bind to the metal. So like this, two coordinate covalent bonds formed. This is we call diurea or biurea. So all these are bidentate ligands. Then hexadentate ligand we have seen, that is what is EDTA -2 we are discussed. So now next we have to discuss about Werner theory of complex. Werner theory of complexes. Werner theory of complexes. Werner theory of complexes. So what are the Werner theory of complexes? According to Alfred Werner, the complexes, it contains two kind of valencies. Two kind of valencies are, one is primary valency, another one is secondary valency. So what are those we will discuss? Just wait 1 minute. Yes. So Werner theory of complexes. So what is the Werner theory? So I told that according to Alfred Werner, coordination compounds can exhibit two different types of valencies. Coordination compounds can exhibit two different types of valencies. So number one, that is primary valency. Primary valency. Then number two, secondary valency. Secondary valency. So what is the primary valency? What is the primary valency? So what is the primary valency? First one we are taking, that is primary valency. So primary valency is a ionizable valency. It is ionizable valency. Ionizable valency. It indicates oxidation state of central metal atom. Remember, my dear students, primary valency nothing but it is a ionizable valency. It indicates the oxidation state of central metal atom. It is satisfied by negative ions only. It is satisfied by negative ions only. Negative ions only. Clear, my dear students? Understand? Yes, come to the secondary valency. What is the secondary valency? Secondary valency nothing but it is non-ionizable valency. It is non-ionizable valency. It indicates coordination number of central metal atom, and it is satisfied by negative or positive or neutral molecules. Remember, my dear students. So all the ligands, whatever the ligands we are discussing now, the monodentate, bidentate, then polydentate, hexodentate, that are. So according to Alfred Werner, coordination compounds contain two types of valencies. One is primary valency, another one is secondary valency. The primary valency is ionizable valency. It indicates the oxidation state of central metal atom. Then, sir, it is satisfied by the negative ions only. Then secondary valency, it is non-ionizable valency. Then it indicates the coordination number of central metal atom. Then it is satisfied by either positive or negative or neutral molecules which are act as a ligands in it. Clear? Understand, all of you? So now what are the primary valency and what are the secondary valency? That one of the compound we'll discuss in it. The primary valency nothing but I told coordination, oxidation state. Secondary valency nothing but coordination number I told. For example, one of the compound is given, that is the CONH3 taken 6, then Cl3, like this will be there, man. The compound ఇలా ఉంది. దీనికి ప్రైమరీ వాలెన్సీ సెకండరీ వాలెన్సీ ఐడెంటిఫై చేయాలి. ప్రైమరీ వాలెన్సీ సెకండరీ వాలెన్సీ ఐడెంటిఫై చేయమని క్వశ్చన్లో అడిగాడు. ప్రైమరీ వాలెన్సీ అంటే మరి మీరు ఏదో అనుకోవచ్చు, దట్ ఈస్ ఆక్సిడేషన్ స్టేట్. ఆక్సిడేషన్ స్టేట్ ఆఫ్ వాట్? సెంట్రల్ మెటల్ ఆటమ్. ఐ టోల్డ్ సెంట్రల్ మెటల్ ఆటమ్ ఫైండ్ అవుట్ చేయాలి కాబట్టి దాన్ని ఎలా తీసుకుంటాం? సో ఏ మెటల్ అయితే యాడ్ చేయాలనుకుంటున్నాం దాన్ని ఎక్స్ అని, క్యాలిక్యులేట్ చేయాలనుకున్న దాన్ని ఎక్స్ అని, దెన్ ప్లస్ దెన్ 6 ligands are there, each ligand neutral ligand ki 0 తీసుకుంటాం, then plus then 3 counter ions are there, each counter ion -1 equals to 0, then so x -3 equals to 0, then x equals to +3. So oxidation state of central metal atom is +3. Clear? Understand all of you? Sir, here one of the point you have to remember. Sir, whatever the monodentate ligands are there, monodentate such as the negative in the low. Negative ligands, monodentate ligand low negative. Sir, what are those? Cl minus, Cl minus, Br minus, I minus, OH minus, H minus. Yes, all these. What are the negative charges are there? So monodentate ligands. For them oxidation state you have to take -1. In case neutral ligands are there, H2O, then ammonia, then ethylene diamine, EN, then methylene triamine, that is TEN. Then whatever the ligands are there, so these are taking a 0, oxidation states are 0, neutral ligands oxidation state. Even pyridine, PY, pyridine, triphenyl phosphine, PPH3, so all these are 0, neutral ligands ki 0 తీసుకోవాలి. Okay, then one more NO neutral ligand ఉంది, CO carbonyl neutral ligand, ఇవన్నీ కూడా 0 తీసుకోవాలి. Then positive ligands కూడా కొన్ని ఉన్నాయి, NO plus ఉంది, then N2H5 plus hydrogonium ion is there, for them you have to take +1. So negative ions ki monodentate అయితే -1, then bidentate ఉన్న SO4 -2 నే తీసుకోవాలి, then CO3 -2 తీసుకోవాలి, C2O4 -2 తీసుకోవాలి, oxalato, that is C2O4 -2, then glycinato, దానికి ఒకటి న్యూట్రల్ ఒకటి మోనోడెంటేట్ కాబట్టి సార్ గ్లైసినాటో, GLY గ్లైసినాటో, దానికి -1 తీసుకోవాలి. సో ఇలా ఆక్సిడేషన్ స్టేట్స్ తీసుకొని సార్ దాన్ని మనం సబ్స్టిట్యూట్ చేస్తే దెన్ ఆక్సిడేషన్ స్టేట్ ఆఫ్ కోఆర్డినేషన్ నంబర్ని ఫైండ్ అవుట్ చేయొచ్చు. Then that is primary valency. What about the secondary valency, man? Secondary valency equals to the coordination number. I told that secondary valency nothing but denticity into number, N. Denticity, monodentate aithe, remember, monodentate aithe denticity equals to 1. Sir, bidentate aithe denticity equals to 2. Then tridentate aithe denticity equals to 3. Hexadentate అయితే density equals to 1. Sorry, density equals to 6. Then say these all are monodentate ligands, ammonias. Then 6 density is 1. Monodentate అన్నప్పుడు 1. Number of ligands how many are there? 6. They can get 6. So coordination number is 6. Secondary valency anna coordination number anna both are same. Primary valency anna oxidation state of central metal atom anna both are same. Clear, my dear students? So you have to identify any atom, any molecule. If they will ask what is the primary and secondary valencies, that we have to note it like this. Okay, so next we have to discuss about valency bond theory. So valency bond theory అంటే ఏంటి? సో valency bond థియరీలో ఆబ్జెక్టివ్ ఎగ్జామినేషన్ కోసం అంటే EAPCET ఎగ్జామినేషన్ కానివ్వండి, JEE మెయిన్స్ ఎగ్జామినేషన్ కానివ్వండి, నీట్ కోసం కానీ valency bond థియరీలో మస్ట్ అండ్ షుడ్గా నీవు గుర్తుపెట్టుకోవాల్సింది 3 పాయింట్స్. సో వాట్ ఆర్ దోస్ valency bond theory? Valency bond theory, that is we call VBT, valency bond theory, VBT. So look at what are the main 3 points I told. So first one, central metal atom can use n-1 into D and ns orbitals for bond formation. For bond formation, central metal atom can use n-1 into D and ns orbitals. Clear? Understand all of you? Then second one, look at ligands can donate lone pair of electrons to central metal atom of vacant orbitals కి ligands lone pair of electrons ని డొనేట్ చేస్తాయి. సెకండ్ పాయింట్ అది గుర్తుపెట్టుకో. థర్డ్ పాయింట్ యూ హ్యావ్ టు రిమెంబర్, ఇన్ ద presence of strong field ligands unpaired electrons are forcefully pair up. It's very important. It is in the presence of strong field ligands unpaired electrons are forcefully pair up. That you have to remember. సరే, ఇందులో వ్యాలెన్సీ బాండ్ థియరీలో అట్లీస్ట్ నువ్వు గుర్తుపెట్టుకోవాల్సింది విచ్ ఆర్ ద స్ట్రాంగ్ ఫీల్డ్, విచ్ ఆర్ ద వీక్ ఫీల్డ్ అంటే, సో స్ట్రాంగ్ ఫీల్డ్ లిగాండ్స్ యూ హ్యావ్ టు రిమెంబర్ NH3, CN, CO. These all are strong field ligands. Then weak field ligands నువ్వు గుర్తుపెట్టుకోవాల్సింది ఏంటి అంటే, సార్ Cl minus, Br minus, I minus, then F minus, all these halides weak field ligands గా గుర్తుపెట్టుకోవాలి. Clear, my dear students? All the halides are weak field ligands. Then nitrogen donors and cyanide, carbon donor and carbon monoxide, that is we call it as CO, carbonyl group we call. సో ఈ రెండింటిని మనం స్ట్రాంగ్ ఫీల్డ్ లిగాండ్స్ గా, ఈ మూడింటిని స్ట్రాంగ్ ఫీల్డ్ లిగాండ్స్ గా గుర్తుపెట్టుకోవాలి. సరే, ఈ నాలుగిటిని వీక్ ఫీల్డ్ లిగాండ్స్ గా గుర్తుపెట్టుకోవాలి. ఓకే, దెన్ ఆఫ్టర్ సో హైబ్రిడైజేషన్ వరకు వస్తే, సార్ ఇన్ కేస్ మాలిక్యూల్ sp హైబ్రిడైజేషన్ అనుకోండి, సార్ లీనియర్ జామెట్రీ. సార్ sp2 హైబ్రిడైజేషన్ అనుకోండి, ట్రైగోనల్ ప్లానార్ జామెట్రీ. దెన్ sp3 హైబ్రిడైజేషన్ అనుకోండి, టెట్రాహైడ్రల్ జామెట్రీ. సో dsp2 అనుకోండి, సో స్క్వేర్ ప్లానార్ జామెట్రీ. దెన్ sp3d2 ఆర్ d2sp3 కానీ d2sp3 కానీ, దట్ బోత్ ఆర్ ఆక్టాహైడ్రల్ జామెట్రీ. రెండు కూడా ఆక్టల్ హైడ్రల్ జామెట్రీని. సో ఈ ఆల్ పాయింట్స్, ఈ 4 పాయింట్స్ కనుక మీరు గుర్తుపెట్టుకుంటే, సో ఫోర్త్ వన్ ఈజ్ అబౌట్ హైబ్రిడైజేషన్. సో హైబ్రిడైజేషన్ అండ్ జామెట్రీస్ గుర్తుపెట్టుకుంటే, దెన్ వీబీటీలో ఏ అప్లికేషన్ ఇచ్చినా మీరు చేయొచ్చు. మనం అట్లీస్ట్ ఒక 4 కాంపౌండ్స్ మనం ఇప్పుడు డిస్కస్ చేద్దాం. దెన్ నోట్ డౌన్ దీస్ పాయింట్స్ విచ్ ఆర్ ఇంపార్టెంట్. బెటర్ టు టేక్ a screenshot. Yes, come to the point, my dear students. Sir, we will take one of the complex. That is sir, in case if you take CONH3 taken 6 plus 3. So according to VBT, we have to identify number 1. So what is the primary valency? Number 2, secondary valency. So number 3, hybridization. Then number 4, geometry. Number 4, what? Geometry. Find what is the primary valency, secondary valency, hybridization, geometry. So then magnetic momentum identify cheyochu. So number next one says that low spin or high spin complex. So low spin complex or high spin complex చెప్పొచ్చు. Then is that stable or unstable compound also we can explain. క్లియర్ మై డియర్ స్టూడెంట్స్, ఇవన్నిటినీ ఒక కాంప్లెక్స్కి మనం చెప్పొచ్చు. ఎలా అనేది మనం చూద్దాం. సో ఇక్కడ క్వశ్చన్లో ప్రైమరీ వ్యాలెన్సీ అయినా అడగొచ్చు, సెకండరీ వ్యాలెన్సీ అయినా అడగొచ్చు, హైబ్రిడైజేషన్ అడగొచ్చు, జామెట్రీ అడగొచ్చు, మ్యాగ్నెటిక్ మొమెంటమ్ వాల్యూ అడగొచ్చు, అది లో స్పిన్ హై స్పిన్ అడగొచ్చు, దెన్ స్టేబుల్ ఆర్ అన్స్టేబుల్. సరే, ఈ క్వశ్చన్స్లో ఏ క్వశ్చన్ ఇచ్చినా మనం చేయడానికి ఆస్కారం ఉంటుంది. ఇఫ్ యూ సీ దిస్ కాంప్లెక్స్, అబ్జర్వ్ ద కాంప్లెక్స్ కేర్ఫుల్లీ వాట్ వీఆర్ డూయింగ్ నౌ. సో ఇప్పుడు ఏం చేయబోతున్నాం అనేది మీరు చూడండి. సో ఫస్ట్ వన్ ఐ టోల్డ్ దట్ ప్రైమరీ వాలెన్సీ హౌ టు ఫైండ్ అవుట్. సో ప్రైమరీ వాలెన్సీ నథింగ్ బట్ వాట్ ఐ టోల్డ్, ఇట్ ఈస్ ఆక్సిడేషన్ నంబర్, రైట్? సో ఆక్సిడేషన్ నంబర్ ఎలా ఫైండ్ అవుట్ చేస్తాం? సో మెటల్ యాటమ్ని ఎక్స్గా తీసుకుంటాం, ప్లస్ then how many ligands are there? 6 ligands. This is neutral ligand that you have to take it as 0, then equals to +3, then x equals to +3. So oxidation state or primary valency that is equals to +3. Then secondary valency, that is we call coordination number. How can you find out? So that is equals to the denticity into number of ligands. Denticity is 1. Then the ligands are 6. So what denticity 1 అని ఎలా తీసుకున్నాం? మోనోడెంటేట్ అయితే డెంటిసిటీ 1, బైడెంటేట్ అయితే డెంటిసిటీ 2 తీసుకోవాలి. Then you can get it is 6, right? Then third one you have to identify the hybridization. So hybridization find out చేయాలంటే, so whatever the oxidation state we are find out, the cobalt +3 oxidation state లో ఉన్నప్పుడు what is the electronic configuration, you must be noted. సో +3 కంటే ముందు ఫస్ట్ కోబాల్ట్ అటామిక్ నంబర్ ఎంత? 27. ఎలక్ట్రానిక్ కాన్ఫిగరేషన్ ఏం రాస్తాం? ఆర్గాన్, దెన్ 3d7 4s2 అని నోట్ చేస్తాం, రైట్? దెన్ CO+3 ఉంటే దెన్ 3 ఎలక్ట్రాన్స్ని రిమూవ్ చేస్తాం, దట్ ఆర్ సార్ ఆర్గాన్ ఇంటూ దెన్ 3d6 దెన్ 4s0, 3d6 4s0 అని తీసుకుంటాం. Next, look my dear students. Sir, here even 4s and the last cell, 4s, then 4p also is there, of course 4d also is there. How many are required that we can take. Then look at 3d orbital lo box electronic configuration తీసుకోండి. Box electronic configuration తీసుకొని electrons ని fill చేయండి. So 1 2 3 4 5 then 6. So first ఒక్కొక్క electron fill చేయాలి, then after it is pair up according to the Hund's rule. Then 4s ఆర్బిటాల్లో ఎన్ని ఎలక్ట్రాన్లు ఉన్నాయి? 0. Then 4pలో ఎన్ని ఎలక్ట్రాన్స్ ఉన్నాయి? సో నథింగ్ విల్ బి దేర్. క్లియర్ మై డియర్ స్టూడెంట్స్? Then here NH3 is a strong field ligand or weak field ligand? So strong field ligand. Strong field ligand ఉన్నప్పుడు in the presence of strong field ligand unpaired electrons are forcefully pair up. ఇందాక ఒక పాయింట్ డిస్కస్ చేసాం మనం VBTలో. So what I told, in the presence of strong field ligand, unpaired electrons are forcefully pair up. So these unpaired electrons are forcefully pair up. How it is, look at. Then these two electrons with pair up of these two electrons, 1 2 3 4 5, right? So within the 3 boxes 2 electrons you can get. Then the remaining boxes are vacant. Observe it carefully. So now, sir, how many required vacant orbitals that we have to take? Coordination number entaithe untundo anni required number of vacant orbitals అవసరం అవుతాయి. So look at ఎన్ని తీసుకోవాలి vacant orbitals అంటే 6 తీసుకోవాలి. 1 2 3 4 5 6. The total, just to make it as box like this, ఏమేం ఆర్బిటాల్స్ ఉన్నాయి ఇందులో? 3d ఆర్బిటాల్స్ ఎన్ని ఉన్నాయి? 4s ఆర్బిటాల్ ఉంది, 4p ఆర్బిటాల్ ఉంది, రైట్? సో ఏమేమి ఇన్వాల్వ్ అయ్యాయి చూడండి. వాట్ ఆర్ దోస్ ఇన్వాల్వ్డ్? దెన్ 3D ఆర్బిటాల్స్ ఆర్ 2, 3D orbitals are 2, then 4s orbital, that is s orbital is 1, then p orbitals are 3, the p orbitals are 3 based on making of these 3 d2sp3 hybridization we call d2sp3 hybridization. sp3 d2 ఉన్నా d2 sp3 ఉన్నా జామెట్రీ ఏమవుతుందని చెప్పాను? geometry that is octahedral geometry. Then d2 sir d orbitals ముందే వస్తే దాన్ని ఇన్నర్ ఆర్బిటాల్ కాంప్లెక్స్ లేదా లో స్పిన్ కాంప్లెక్స్ అంటాం. సర్ d తర్వాత వస్తే sp3 కి తర్వాత వస్తే దాన్ని అవుటర్ ఆర్బిటాల్ కాంప్లెక్స్ అని హై స్పిన్ కాంప్లెక్స్ అని అంటాం. సో ఇస్ దట్ లో స్పిన్ ఆర్ హై స్పిన్? సర్ ముందే వచ్చింది కాబట్టి ఇది లో స్పిన్ కాంప్లెక్స్. After the formation of hybridization, is there any unpaired electrons? Unpaired electrons ఉన్నాయా? All are pair up. So unpaired electrons లేకపోతే then magnetic momentum ఏం చెప్తాం? Diamagnetic in nature. Then at last, effective atomic number find out చేయాలంటే effective atomic number ఎలా find out చేస్తాం? Effective atomic number equals to atomic number of metal minus oxidation number plus 2 into coordination number. Yes, is that visible at last, my dear students? So look at, yes, and so atomic number of cobalt is how much? 27. Then minus oxidation state, how much you got? Plus 3. Then 3 plus 2 into coordination number enta? 6. Then 27. Look at 27. So minus 3 you can get 24. 24 plus 12. Then you can get 36. Wherever the 36 you can get, that is stable. 36 kante above unna, 36 kante below unna, coordination number takku unna, then it is unstable compound. Clear? Understand, my dear students? So ఏమేం చేసాం? ఏమేం ఐడెంటిఫై చేసాం? ప్రైమరీ వ్యాలెన్సీ ఐడెంటిఫై చేసాం, సెకండరీ వ్యాలెన్సీ ఐడెంటిఫై చేసాం, hybridization based on the geometry, magnetic momentum, low spin, high spin, stable or unstable. Stable or unstable అనేది ఎలా చెప్తాం? Sir, effective atomic number in case if you get 36, that is stable. Sir, in case less than 36 or more than 36, then it is unstable. Then high spin and low spin అని ఎలా చెప్తాం? So low spin in case it is dsp2 or d2sp3 అంటే d ఆర్బిటాల్ ముందే వస్తే దాన్ని మనం లో స్పిన్ కాంప్లెక్స్ అంటాం. అదర్వైజ్ sp3 దెన్ sp3d2 ఇలా వస్తే దాన్ని హై స్పిన్ కాంప్లెక్స్ అంటాం. ఓకే, ఎస్ మై డియర్ స్టూడెంట్స్, ఎస్ నోట్ ఇట్. వన్ మోర్ కాంపౌండ్ విల్ డిస్కస్. నెక్స్ట్ కాంపౌండ్ ఒక వీక్ ఫీల్డ్ లిగ్యాండ్ తీసుకొని మనం నెక్స్ట్ కాంపౌండ్ని ట్రై చేద్దాం. సో దట్ ఈస్ నికెల్ కాంప్లెక్స్ వీఆర్ టేకింగ్ NiCl4 minus 2, like this will be there. So this is the complex, observe it carefully. So ఈ కాంప్లెక్స్ కి మనం ఏమేం ఫైండ్ అవుట్ చేయాలని చెప్పాను. సో ఫస్ట్ థింగ్ ప్రైమరీ వ్యాలెన్సీ, నథింగ్ బట్ ఆక్సిడేషన్ నంబర్. ఎలా ఫైండ్ అవుట్ చేస్తాం? నికెల్ కాబట్టి దాన్ని x తీసుకున్నాం, x then plus 4 into each one minus 1 equals to minus 2, then x equals to plus 2 you can get. Then next secondary valency find out cheyali. Secondary valency ante coordination number, right? So coordination number ela find out chestam? So density into number of ligands, denticity chlorine 1, then number of ligands are 4, then you can get 4, coordination number is 4. Then later what you have to take? So third one, that is hybridization, you have to find out. Hybridization find out చేయాలంటే నికెల్ అటామిక్ నంబర్ ఎంతో తీసుకోవాలి? నికెల్ అటామిక్ నంబర్ 28. ఎలక్ట్రానిక్ కాన్ఫిగరేషన్ తీసుకుంటే ఆర్గాన్ 3d8 4s2. 3d8 4s2. Just wait, my dear students, I will take water. Yes. So come to the point. So oxidation state nickel ఏముంది? So nickel +2 oxidation state. +2 అన్నప్పుడు ఎన్ని ఎలక్ట్రాన్స్ రిమూవ్ చేయాలి? 2 ఎలక్ట్రాన్స్ రిమూవ్ చేయాలి. దెన్ ఎలక్ట్రానిక్ కాన్ఫిగరేషన్ ఏమవుతుంది? 3d8 4s0 then 4p. Of course 4p also 0. Then next box electronic configuration if you take. Then, sir, 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8. Then s orbital లో electrons లేవు, then p orbitals లో కూడా electrons లేవు. As usual గా తీసుకున్నాం 4s then 4p. Then this is 3d. Sir, ఇందులో ఉన్నది strong field ligand, weak field ligand. So Cl minus is weak field ligand, you have to remember. Weak field ligand. Sir, in the presence of weak field ligand, in the presence of weak field ligand, sir, unpaired electrons are forcefully pair up. Unpaired electrons, sorry, I'm very sorry, sir, unpaired electrons does not pair up. Does not pair up. సో పెయిర్ అప్ అవ్వట్లేదు అంటే ఎలక్ట్రాన్స్ని యాజ్ యూజువల్గా తీసుకోవాలి. దెన్ 1 2 3 4 5 దెన్ 6 7 8 యాజ్ యూజువల్ ఎలక్ట్రాన్స్, దెన్ s ఆర్బిటాల్, దెన్ p ఆర్బిటాల్స్ ఆర్ 3 we are taken. So this is 4s then 4p. So here how many what is the coordination number 4? So 4 unte 4 vacant orbitals are required. 5 unte 5 vacant, then 6 unte 6 vacant orbitals are required. So 4 vacant orbitals are required, so that's what we are taking. So 1 2 3 4. So ఏమేమి ఉన్నాయి? So s orbital is 1, then p orbitals are 3, then totally that is sp3 hybridization. So whenever sp3 hybridization is there, geometry we can get it is tetrahedral geometry. Understand, my dear students? Right. Then after tetrahedral geometry, is that low spin or high spin complex? Sir, here so d orbitals మనం యూజ్ చేయలేదు కాబట్టి then we can say it is high spin complex. So it is high spin complex. So then high spin complex అనేది దేన్ని బేస్ చేసుకొని చెప్తాం? Sir, generalగా unpaired electrons ఉంటే then we call it is high spin complex, and as well as paramagnetic nature. It is paramagnetic or diamagnetic? Paramagnetic nature due to the presence of unpaired electrons. Then at last, so that is effective atomic number you have to find out. Effective atomic number, that is atomic number of central metal atom minus oxidation number plus 2 into coordination number. Atomic number of nickel is 28, then oxidation state 2, then plus 2 into coordination number. Coordination number is 4, then 26 plus then 8. So 8 plus 26, how much you can get, man? How much you can get? 26 plus 8, 30, 34. Yes, 34, it is less than 36, right? So once less than 36, it is unstable compound. We call it as unstable compound. So like this, the primary valency we can identify, then secondary valency we can identify, then hybridization we can identify, then tetrahedral or high spin or paramagnetic, that we can identify. Based on these, what type of questions they are asking, that we'll discuss. So first note down these complex. Yes, based on this, sir, one of the question we'll discuss. So note down the question. Note down the question. Match the following columns. Match the following. Match the following. Such as column 1, then column 2. Such a compounds are mentioned. NiCN taken 4. Then a minus 2. Then B, NiCO taken 4. Then C, NiCl4 minus 2. Now only we have seen this complex, right? Then this is geometry, structure. Structures are mentioned. First one is tetrahedral, then paramagnetic. Number 2, tetrahedral diamagnetic. Tetrahedral diamagnetic. Then number 3, square planar diamagnetic. Yes, look at my dear students. Sir, here already one of the compound we have seen, that is దీనికంటే ముందు డిస్కస్ చేసిన కాంపౌండ్ ఏది NiCl4 2 minus. It is tetrahedral. We have seen hybridization is sp3 అయితే tetrahedral అవుతుంది. tetrahedral మళ్ళీ దెన్ పారామాగ్నెటిక్ అని చెప్పాం. ఎందుకు పారామాగ్నెటిక్ అని చెప్పాం? అన్పేర్డ్ ఎలక్ట్రాన్స్ ఆర్ దేర్. Then the remaining 2 you have to see. such as first one, in case if you take NiCN taken 4 minus 2, taken 4 minus 2 if you take. See, look at this is x plus 4 into minus 1, it is equals to minus 2. Then x we can get plus 2, oxidation state is plus 2 for this. Okay, oxidation state is not required now. So Ni plus 2 oxidation state తీసుకున్నప్పుడు 3d8 electronic configuration వస్తుంది. 4s0, then 4 right? Then is that strong field ligand or weak field ligand? Strong field ligand. Then a d electrons 1, 2, 3, 4. So d electrons 8 electrons ఒకే దాంట్లో అంటే pair up అవుతాయి. Then s orbital, then p orbital, like this will be there. So coordination number 4 ఉంది కాబట్టి so 4 vacant orbitals are required అయితే 1, 2, 3, 4. Then hybridization we can expect, that is dsp2 hybridization. dsp2 hybridization. dsp2 hybridization ఉన్నప్పుడు look at, then square planar geometry అవుతుంది. Square planar geometry. After hybridization there is no unpaired electrons in it, unpaired electrons leave కాబట్టి then diamagnetic అవుతుంది. So square planar diamagnetic for the first one. Then అట్లే NiCO taken 4 చూస్తే NiCO taken 4 second one. NiCO taken 4 చూస్తే, so look at my dear students. So nickel oxidation state is 0. So nickel atomic number 28. Then electronic configuration 3d8 to 4s2. But here you have to observe, that is which is carbonyl group is, it is strong field ligand. Then box electronic configuration if you take, unpaired electrons are forcefully pair up. So which are even s orbital lone electrons kuda induloki vachesi, then all these orbitals are completely filled like this. Then s orbital is there, then p orbitals are there, then these are the s orbital, these are the p orbitals. S orbital, then coordination number 4 is there. So any orbitals required అయితే 1, 2, 3, 1, 2, 3, 4, right? 4 are the required 4. Then hybridization is sp3. Yes, sp3 hybridization. sp3 hybridization ఉంటే ఏ geometry అవుతుందని చెప్పాను? Tetrahedral geometry. Yes, tetrahedral geometry. This is tetrahedral geometry, right? Then there is no unpaired electrons already pair up. Then this we call diamagnetic. Clear, my dear students? So second one is this. So like this we have to find out all these things. Actually this question, it is given in the 2021 shift 2 EAPCET examination lo ichina question idi. 2021 shift 2 EAPCET లో వచ్చిన క్వశ్చన్. సో జనరల్గా EAPCET అంటే ఇంజనీరింగ్ అగ్రికల్చర్ ఫార్మాటికల్ కామన్ ఎంట్రన్స్ టెస్ట్. దట్ యూ హ్యావ్ టు రిమెంబర్, మై డియర్ స్టూడెంట్స్. ఓకే, క్లియర్? థ్యాంక్ యూ ఆల్. నువ్వు ఒక్క లైవ్లో ఎవరు లేరు.